right? So previous we have discussed flip-flop. What is the flip-flop and what are the different types of the flip-flops are there? What are the characteristic features of the flip-flops? Now from the types of flip-flop only, now I am going to explain different types of the flip-flop. Now under that, first one, RS or SR flip-flop here, right? So here the name itself, SR flip-flop again. So flip-flop, right? It is going to take the inputs generating the output. So the output is one output is complement of the another output. So if you check here, RS flip-flop, right, which is going to take 3 inputs, right? It is going to take what here? 3 inputs, and which is generating the 2 outputs, where one output is complement of the another output. So what are these 3 inputs? Means it stands for S, R as well as a C. So S stands for set, right? It is taking one input as a set and one more input as what here? Reset, and one more input is C. C stands for the clock signal, right? So whenever the clock signals moves from the positive transition from 0 to 1, then only it is going to change the output here. So the output is what here? You have output, one output is complement of the another output, right? So here I have given the working of RS flip-flop, right? So just you have to remember this diagram as well as this table here, right? So how it is going to work? So the RS flip-flop, right? So the output of the RS flip-flop, it is going to generate the output based on what? Based on the values of the input values here, right? So when the clock transition value, right, if it is not changing, that is nothing but 0, then in that case, so the output is not going to be, right, there will not be any change in the output. That is nothing but, right, when clock value is 0, then irrespective of the values of S and R, right, the output is not going to be changed. But once if the clock signal changes from positive transition from 0 to 1, then based on the combinational values of S and R, the output is going to be changed, right? So these 2 points you have to write under what? Working of RS flip-flop. So first point is what? The output is not going to be changed, right? So if the clock signal is 0, then it is not going to change any output here, irrespective of what? The values of R and S, right? Once the clock transition moves from 0 to 1, right, then in that case the output is going to be changed. So depending upon what? Depending upon the values of S and R here, right? So just clock signal I am using here for what? So the output has to be generated here based on what here? Clock signal. When it is 0, no change. When it is moving from 0 to 1, for all the states it will be what here? 1 only. Now first case, right, first point what you write? From this table only you are going to write the theory points now, right? When S is equal to 0 and R is equal to 0, then the effect on output is what here? No change, right? It is not going to be change anything. That's why here it is what? No change output. And second case, if you check, if S is equal to 0 and R is equal to 1, so R is nothing but what here? Reset. In second case, reset state is activated. R is equal to 1 here. So reset state is going to be activated. Then in that case, reset is nothing but what here? Clear. So the output is reset to what? 0. Right? So reset stands for what here? Clear. So here the value is what here? 0. Now next one is when S is equal to 1 and R is equal to 0. So in which place it is 1? S. Then set state is going to be activated and the output will be what here? 1. See here, set to 1. And last one, if you check, special case here, S is equal to 1 and R is equal to 1, then in that case you cannot find out whether the output value is 0 or 1. That is nothing but what? It is known as a intermediate state or the forbidden state here. So because of the time delay, either the output will be what here? Internal time delay, the output will be 0 or 1 here. You cannot identify. That's why here it is known as a intermediate state or the forbidden state. Now what is this Q of t as well as the Q of t plus 1, right? So this Q of t is considered as a binary state of the output, right? It is considered as what here? Binary state of the output Q at the given time. That is known as a present time. right? It is known as what here? Present time or the present state. So what is q of t here? So this q of t is considered as a binary state of the output q. So at the given time, that is nothing but what here? Present time or the present state. And when you are coming to what here? Q of t plus 1, right? So this q of t plus 1, it is also considered as it is a binary state, again binary state of output q, right? Binary state of what here? Output q after the clock transition. That is what? When the clock transition moves from 0 to 1, then in that case it is known as a next time, right? So present time is nothing but what here? Binary state of the output q, right? At the given time, that is nothing but what here? Present time. And q of t plus 1 is nothing but binary state of the output q after the clock transition. When the clock transition moves from 0 to 1, if it is 0, output will not be changed here, right? When it is moving from 0 to 1, means you are moving to what? Next time. That is nothing but q of t plus 1. So q of t plus 1 is nothing but binary state of the output q, right? So after the clock transition, that is when it is moving from 0 to 1, that it is known as what here? Next time, right? So till here you are going to write about what here? RS flip-flop. So first one you will write, explain the symbol. So RS flip-flop, right? So which includes what here? 3 inputs S, R, C, and which is generating 2 outputs, where one output is complement of the another output. Now working of RS flip-flop, I told, when both the inputs, see, clock signal is 0, then the output is not going to be changed. Once the clock signal changes from 0 to 1, the output will be changed based on what? Based on the values of S and R. So these 2 points you have to write under working. Afterwards, all the points from this table. S is equal to 0, R is equal to 0. So these points you are going to write. Next one we have D flip-flop. Next one is what here? D flip-flop. So this D flip-flop, it is known as a data flip-flop, or it is also known as a delay flip-flop, right? Again, so this D flip-flop, so which includes what here? Logical symbol, which is taking only one input, that is nothing but the data input, right? Along with what here? Clock signal, and which is generating what? 2 outputs here, where one is complement of the another output, right? So D flip-flop includes only single input. That input is known as a data input along with the clock signal, and it is generating what here? 2 outputs, Q and Q dash. So D have taken, when it is 0, it will be 0. When it is 1, it is going to be 1. Again clock signal, initially it will be 0, right? So when it is moving from 0 to 1, then only the operation is going to be performed here. So why I am saying here delay flip-flop, right? D flip-flop is also known as a delay flip-flop. Why? Because the output is going to be delayed for one clock transition, right? So before, when it is moving from 0 to 1 here. So that's why it is also known as what here? Delay flip-flop. Now here I have given one more diagram, right? So wiring of D flip-flop, wiring of what? D flip-flop using RS flip-flop, right? So taking single input, see here. So D is directly connected to what here? S, right? And I am taking what here? Invert of D, right? So D complement, that is connected to what here? R. And along with that here, what here I am using? Clock signal. Why? Because RS flip-flop we have seen 2 inputs S and R along with what here? C, clock signal, and it is generating what here? 2 output, that is nothing but Q and Q dash, right? So only one point you are going to write, right? The data input directly connected to what here? S input of the RS flip-flop, and the inversion of data input, it is connected to what? R input of the RS flip-flop, and it is generating what here? 2 outputs, Q and Q dash, right? One more we have commercial D flip-flop. One more is what here? Commercial D flip-flop. So if you check this diagram here, again data input is there. So you have 2 more inputs, that is nothing but preset, and next one is clear, right? So these 2 extra inputs are known as asynchronous inputs. They are known as what here? Asynchronous inputs. So they does not, right? They does not depend upon this clock signal. Whereas this data input, so these 2 are known as what here? Asynchronous inputs. Whereas data input is known as a synchronous input. Now what is the difference? Asynchronous and synchronous means this data input always depends upon what? Clock signal, right? So when the positive transition of the clock signal moves from 0 to 1, then the input is going to be applied. Whereas in case of the asynchronous input here, preset as well as a clear, right? So preset is always set to what here? 1. Right, and clear is used to what? Clear the flip-flop, that is nothing but it is taking the value 0 here, and these two inputs does not depend upon the clock signal here. That's why they are known as what here? Asynchronous inputs. And data flip-flop, the input will depend upon the clock signals, hence it is known as a synchronous input.